All right, today we're jumping into something, well, it's pretty out there. It's a concept for a whole new kind of internet, a neural internet, from a creator named Guy Lakeman. It's called Neurotonet. And the goal is, get this, a global, democratic intelligence. Yeah. So let's try to wrap our heads around this. Okay, so right away, what are we even looking at here? This is the master diagram. You've got this brain-like thing up top. The whole Earth is covered in this crazy web of connections, and then you see words like moonball and intelliballs. The source material actually calls this entire thing the Global Intelligence Furball. And honestly, that's the perfect place for us to start. Yep, you heard me right. The Global Intelligence Furball. It's definitely a name that sticks with you, and it's describing an idea that is just unbelievably ambitious. So let's unpack what that name really means. Okay, so the formal name for this furball is Neuronet, and its creator's definition is an efficient global broad-spectrum democratic intelligence. Whoa, that's a mouthful. But every single one of those words is doing some heavy lifting. Efficient is all about how it saves data. Global is about its insane scale. And democratic, well, that points to a really big philosophical goal of putting this power in everyone's hands. And when we say global scale, we are not messing around. The plan calls for deploying 10 billion of these little neuron units all over the world. To put that in perspective, that's more than one for every single person on the planet. This isn't just a network we're talking about. It's supposed to be a cognitive system for the entire planet. So the big question is, how in the world do you get 10 billion of anything to work together? Well, the secret sauce, at least according to this plan, is in the core building block of the whole network, the self-training neuron. Let's dig into what each one of these things is supposed to be. Let's go back to our big, crazy diagram for a second. That thing right at the very top, the one that looks like a brain cell, that's the key to everything. It's the global, large, smart neuron model, and it's the fundamental piece of the puzzle. Every single one of those 10 billion units is one of these. Now, here's where it gets really interesting. Each neuron is basically its own little self-training processor. It learns and adapts all on its own. But the real kicker is that it's agnostic. And what that means is you can throw pretty much any kind of data at it. Images, text, audio, you name it. And it can just figure it out. No human has to prep the data first, which, is a massive problem for a lot of AI systems right now. So this brings us to what's probably the biggest technological claim of the whole system, how it stays so efficient. And the creator uses an analogy that you and I use literally every single day: MPEG video compression. So here's the basic idea. Right now, a lot of AI models have to share these gigantic libraries of data, these huge vector databases, just to stay on the same page. Neurotonet says, forget that. Instead of sending the entire library over and over, you only send these tiny little packets of information that represent what just changed, the new stuff it learned. They call them token weight change packets. And this is the perfect way to think about it. You know how when you're streaming a video, it's not sending you a whole new picture 30 times a second? No way. It's just sending the little pixels that moved or changed color. Neurotonet wants to do the exact same thing, but for intelligence. And that would, in theory, dramatically slash the amount of bandwidth this global brain needs to learn and grow. Okay, so we've got 10 billion smart neurons, and they can all talk to each other super efficiently. But how do you actually, physically connect them across the entire planet? This is where we get into the hardware that would tie this whole furball together. Let's look back at the bottom of our diagram, because this is where the physical stuff lives. We're talking about satellite sun-grabbing intelliballs orbiting the Earth, and they're all connecting back to a central hub called the moonball. I mean, you can't make these names up. This is the hardware that would make it all possible. It sounds like it's pulled straight from a sci-fi novel, right? So you'd have these solar-powered satellites, the intelliballs, that are basically acting as relays in the sky, connecting all the individual neuron models down on the ground. And then the moonball would act as the master coordinator, the central switchboard for the entire network. Okay, so we've got the neurons, we've got the network, but all of this is really building towards the philosophical heart of this project, which is to totally challenge how we build intelligence today. The main goal is to create a powerful AI that doesn't need any traditional data centers at all. And here it is, a direct shot at the current way of doing things. The source argues against these massive energy-hungry data centers, calling them intelligence factories. Neurotonet is designed to be the complete opposite of that centralized, resource-guzzling model.
And that leads us to the question of control. See, by making the network decentralized, by promoting open ownership, the whole idea is to wrestle the power of AI away from a handful of giant corporations and put it into everyone's hands. That's what they mean by democratic intelligence.
And this is what it all boils down to for the actual user. The whole point isn't just to build some crazy new tech. It's to empower every single person. The idea that you could guide your own team of AI agents to learn anything you want, to create without limits, to, and I quote, be your own professor. So what do we make of all this? Is Neuronet a brilliant blueprint for a decentralized, efficient, and truly democratic global AI? Or, with its moonballs and intelliballs, is it just a really fun, futuristic fantasy? The real question is, where on that spectrum do you think the future of intelligence is actually going to land?